Are you recording? You're all
Yeah.
set? Okay, great. So hi, and thanks for inviting me to come and talk today.
You're welcome.
My name's Jacob Jeremko. I'm a radiologist and a professor of radiology and Canada CFAR AI chair in the Department of Radiology here. I'll show you on the next slide. And so my work is to do, as a radiologist, I read images, X-ray, CT, MRI all the time. And then on the academic side, my interest is in developing AI to do that. In a sense, putting myself out of a job. But as we'll see from this talk, we might not be quite putting ourselves out of a job just yet. So I'm going to talk about challenges in medical imaging AI, mainly centered around data and liability. So just my current roles, I'm a radiologist, a pediatric and musculoskeletal radiologist. I have 2 fellowships in that. And I have Canada CFAR AI chair, which is, there are about 120 of these across Canada. And I'm the only one of those that's a physician. Everybody else is a PhD scientist. I do have a PhD in biomedical engineering, but I'm the only one that's a practicing physician in the crowd. Because the AI, those CFAR chairs are meant to be people who are, doing a lot of AI coding But interestingly, I do have quite a background in that because starting from 1999 in my PhD thesis, we were using artificial neural networks, which are basically almost the same thing as, those are the sort of precursors of the fancy AI tools that we now have today. I'm also a partner of MIC, Medical Imaging Consultants. That's Edmonton's biggest radiology group. And I'm a co-founder of a startup company. Actually, there's 3 of those that I've co-founded. Meadow is the one that is most relevant here. And I'm a fellow of the Alberta Machine Intelligence Institute. So lots of different hats, but these roles all kind of come together in discussing medical imaging AI. So this course, it sounds like it's about, it's really future forward. You're really looking at future technology in a diverse set of fields. So my field is medical imaging. We're going to talk about data ownership, data privacy, and liability as the major issues. So what happens in medical imaging, and how does AI contribute? Well, the task of a radiologist like me is to basically take complex image data and distill it into a text report containing the findings, diagnosis, and plan. So basically we take, those are my boys looking at a CT of the abdomen and an abdominal X-ray. And the CT of the abdomen has, several hundred or a couple thousand images. And I look through all those images and take in that pile of visual data and try to process it into something that makes clinical sense. It's like you have appendicitis, or it looks like you have pancreatic cancer, like that. And an X-ray, similarly, is just one image, but it contains many thousands of pixels, and so there's also a bunch of data in that. And I'm basically synthesizing that down into a couple of sentences that are meaningful clinically. So convolutional neural networks, which are the tools that artificial intelligence is using to look at images, basically can do that. So what they do, with the picture at the bottom there's a chest X-ray, and on the right side there's an AI algorithm has been run to detect that something's abnormal in that area. It's got like a little heat map, and it has detected that there's something unusual about the right lung base. And the answer is it's pneumonia probably. And so I, as a radiologist, up until 2 or 3 years ago, you couldn't automate that. You had to have a person look at the picture and say, I think that's pneumonia. But nowadays, after training AI tools on thousands of X-rays, you can start to do things like have the AI tool detect whether the X-ray is normal or abnormal, and then if it is abnormal, to guess to make a stab at what's abnormal in it. So you can imagine that my colleagues in radiology are a little nervous because this is, if you take something that used to be a skill that requires, like I have 18 years of post-secondary education. It takes a long time to get trained to do this stuff. But if you can replace that with a computer, then it makes it more accessible, more reliable, quicker, probably cheaper. So it's definitely the field of image interpretation is anything which is primarily about interpreting images can be can really change with AI. Now, pathology is definitely in that. Lab medicine and pathology is just like radiology, just as much effective. The computer can look at the slides, look at the way the cells look, just the same way, and detect patterns and identify what's in the slides. A computer at this moment can't actually do the dissections, but there are machines and robots coming that can help with that too. So those of us who in fields that are not directly seeing patients most of the time are definitely looking at some pretty big career changes as a result of the AI coming down the pike. So all of this brings a lot of ethical and legal concerns to the fore. And so I have, I wrote this paper, and I've been involved with several others from the Canadian Association of Radiologists, which has a task force that's looking into what to do with AI in radiology. And so this one was a few years ago now, but it is a very interesting group to work on. Very diverse expertise. We have people. We have radiology residents and staff. We've got a lawyer. We've got a couple of computer scientists. We've got professional ethicists, medical students, health systems researchers. So a whole bunch of different people looking at AI from many different perspectives, and that's part of what we can do today is look at this from our perspectives. So with AI now coming to the fore, we see that medical data is being used for secondary purposes. Up until a few years ago, if you went to your doctor and you want to get seen to, maybe you have chest pain and you want to talk to your doctor about what could be going on, then you provide your doctor some data about you, some very intimate or personal information about yourself, and they use that information to form an opinion that and provide management plan to help you with to help you get better. So that's like an individual doctor-patient kind of transaction, or it's like a patient and a healthcare team that's just using the data to help you. But that data that's being collected is also something that can be really useful in bulk, so that you could say, well, of the last 1,000 people who came in with chest pain, what did they all actually have? And what did the 50-year-old white males have when they came in with chest pain versus the 25-year-old indigenous females or something, right? So like you can take that data and do secondary analysis with it from a statistical point of view. And nowadays you can use that data, thousands of patients. You can train an AI network to actually come up with the diagnosis or a management suggestion. So this is a secondary use of patient data for supervised AI training. You can even do unsupervised training, which is where you just give a whole bunch of data to the AI network and let it think about clustering the patients into different groups. You say, what are the group families of patients that kind of fit together most closely? And that can actually provide some insights into disease that we might not have thought of, because it's kind of unstructured. But most AI training is currently done as supervised training. So this data was collected first to care for the patient, but is now valuable in bulk to train AI. And this bulk use of data, which was not really contemplated 100 years ago, brings up a bunch of ethical and legal issues. One might argue, actually, that there's a real opportunity here. National healthcare systems like Canada, the UK, Australia, we have single-payer databases. And so what's special about a single-payer database is that you have, just like in Alberta, you have your Alberta healthcare number, right? The PHN that you have here, 9 digits. It identifies everybody who's in Alberta. And the reason that everyone uses it is because if you put in that magic number, the government will pay for your healthcare. If you don't have one of those, then you have to pay it yourself, and it can be many thousands of dollars. So everybody uses it, and the government collects all this information, or the health region collects that information linked to that number, and you have full population data. Now, that's important because So on one of my fellowships, I worked in the US, I was in Boston, and I was working with a hospital group. There was about 10 hospitals and clinics affiliated with it. And so they had their system, like their archive of all the patients that they saw. But the problem is that if you used AI to train on that database, you're just using, there are thousands of patients in there, but they're basically the thousands of patients that could afford to go to the private health system that I was working for. So, wealthy white people primarily. So it would very, very hopelessly underrepresent the people in certain neighborhoods in Boston. So in that case, if you were looking at conditions, if you're doing a study of like people who come in with chest pain and it's only the people from that hospital group, they're going to have a different distribution of disease than the people from in other sectors of the population. And that's a big problem in the US, is that there's sort of fragmentation in health data. But in Canada, that's not the way it works, because if you're in Edmonton zone, you have data from everybody of all walks of life and all genetic backgrounds and socioeconomic situations in Edmonton. And then you actually have that across each province, like Alberta Health Services collects that for all the province. Actually, Alberta Health Services is now fragmenting into 4 different parts, so there's some complexity there, but in theory, the data shouldn't be affected by that. So this is highly desirable because you can get accurate patterns of disease and do training that is unbiased. And it's something that's really desirable about Alberta or Canada, Norway, Sweden, Finland, these kinds of places. And so it gives us a real potential to lead the way in medical imaging AI. And as you can see at the graph there, the value of data for individual patient care maybe is dropping over time, but the value of data for machine learning is increasing over time. So why do we care about these biased data sets? Well, it's pretty obvious, because we want the AI networks to make decisions that represent the population they're actually working in. So a classic story from some years back, actually, was that face recognition algorithms, those are those things that, it's a little creepy. I don't know if you look on Google Photos or Apple Photos, and you can see, it suggests like who these people are that might be. It'll have a picture of several different faces, and it'll say, this person appears a lot in your photos, right? What's their name? You can type in their name. So that's a face recognition algorithm. It's identifying that face in all your pictures, your partner or your kid or something. So, but interestingly, it turns out these facial recognition algorithms were initially trained on mainly Caucasian people. And so there was a very embarrassing thing for Google where it tagged 2 African Americans as gorillas through the facial recognition software. So that's a bad look. That's very optically unfortunate for Google, and just demonstrates that their training should have included a whole bunch more people from different ethnicities. So what did they do about it? Well, you would think they'd go back and train using mixed race data, obviously, but actually what they decided to do is to not label gorillas at all. So, and this is recent, as of even last year, and New York Times testing, if you put gorillas into the photo app, it still couldn't find them. So they decided, look, we're just not going to talk about gorillas. There's just no gorillas anymore. There's just no gorillas in our database. So, and apparently Apple, same thing. So that's a kind of a, we fear lawsuits and we don't want to cause trouble kind of approach. But they could easily solve it by just using, because obviously, that's a gorilla, that's not a person, but they look different, right? So you could train an AI system to detect that as long as you had an unbiased data set. And just hammering that home, bias can actually be quite dangerous. Here's an example. Self-driving cars are supposedly more likely to drive into black people. Now, so that could be, in fact, you can imagine that the self-driving car is being trained to detect objects in front using their radar. And once it detects the object in front, it I would decide what that object is. Is it a pylon? You know, what is this thing? And is it a person? And then try to avoid it. Now, it is possible that there's a technical thing, because if you have dark skin, you might actually at night be harder to detect or something like that. But I think this probably is just the same in the daytime. It's just like the definition of a person on the data set is more of a white person or a light colored person. It's kind of like the skin color crayon from years ago, you know. So these are, you know, very current AI algorithms that are very publicly obvious, that are using clearly some pretty biased data sets. And we can't afford to do this in medical imaging or any healthcare AI. We need to use an unbiased data set to provide appropriate care. So we can talk about data mining, and this is an important point because effectively, if you look back here, we're talking about these data sets, right? So how do you develop a data set? Well, you're going to want to pull data from many different places, many different people. Are you allowed to do this? Like, who is allowed to do this? Is the health region allowed to do it? Is Google allowed to do it? Who owns your healthcare data? So an interesting thing about that. So you go into the doctor, you came in, you've got chest pain, you get this, you get a chest x-ray because you had chest pain. So do you own that chest x-ray? The answer is no, you don't own the chest x-ray. The person who took the chest x-ray, i.e. the radiology clinic or the hospital, owns it. They're the data custodians. But there's a special right, there's some special rights associated with it. The hospital is responsible, like the data custodian is responsible to protect that data from unauthorized use or inappropriate use. It has to safeguard it carefully. And also you have a right of access to the data. So like you can request a copy of your chart or a copy of your x-rays. There could be a fee associated because it's, you know, you'd imagine that you have to pay someone to go pull it out of the chart. But you have the right to access it. So this has been tested. This is a well-known long-time thing, even from the days of paper records. The hospital owns the paper record, but the patient has a privacy interest in the data. And it's a bit like with land. Like when you buy a house, or you buy basically any property, there's a line in there usually, if you're buying it from the Crown or something, it says, accepting thereof mines and minerals. So you don't, basically you own the surface, you own the first few feet of land so that you can build, you know, a basement. But if there was oil deep underneath your land, the Crown probably still owns that, unless it's been specifically sold. So in Canada, the Crown, like the King, the government, owns the mineral rights by default, but whereas the landowner owns the surface rights. So maybe the landowner is like the patient, where you're entitled to your patient, where you're entitled to have some protection of your personal data. But maybe these mineral rights, maybe it's okay for the government or data custodians to authorize people to use it in bulk, kind of like mining your data. So maybe, right? Maybe, maybe not. So when is data mining okay without explicit consent? That's a pretty tricky question. Like, how do we determine who gets to use your data and when and for what purposes? And what rights do you have over it? Clearly you have some right to it, even though it's not yours according to Canadian law. So I think that's pretty complicated. I'm not a lawyer, but it does indicate that you can't just, like, even the big AI companies in regular life, right, in non-medical space, they are basically scraping data from the internet, all the publicly available data that you get from the internet. There's a lot of proprietary information, like behind paywalls on the internet, that they're not allowed to have. And so is there a giant paywall or a giant barrier that blocks people from using any medical data, or do you have to, or are there ways around it? So super complicated to get access to medical data, which I personally think is as it should be. And that's because medical images are super, super sensitive. They're more sensitive than almost anything else. You could argue genetic data is probably even more sensitive, you know, the genome, your genome. But these medical files, these medical images contain a lot. So they're usually, you know how like a photograph, the default file name is a JPEG or JPG? Well, for the medical images, it's a DICOM. And the DICOM file header contains a whole bunch of fields: name, birth date, address, physician, height, weight, BMI, pregnancy status. So all this information that gets populated, usually automatically when you enter a hospital. And it's in these different fields, many of which are proprietary. So if you take the header, like the sort of that part of the file, and you say, well, I'd really rather that nobody knows my pregnancy status, you know, or my BMI, you can ask the computer to remove all, to like clear the fields. Any field called, you know, field number 0010 called pregnancy status, we're going to clear that field. But the problem is that, like, Philips, for example, uses the standard fields, but it might also add another field of its own with its own name to it. You can add, so, you know, you might call it, you know, pregnant, yes, no, or something. So that field is Philips' own choice. You can add, you know, anyone with the DICOM standard can add those. So if you're anonymizing, you don't necessarily know that that field is still there. So it's very hard to get rid of stuff in a DICOM file. What people have been doing a lot lately is actually just deleting the entire header. So you just change it to a different format. You change it to a TIFF image or a PNG image, and you just remove, you're just not even looking at DICOM files because we're sort of too nervous about what's in there. It's a very, it's a bit of a minefield. So, but unfortunately, even if you remove all the text, you know, even if you do that, you remove all the header information, medical images are still uniquely sensitive. And this is because they're private images inside your body. Like, they're intimately linked to your diagnosis and prognosis. And this data can fall into the wrong hands. So for example, if you're an athlete with knee arthritis, you know, imagine, I mean, who knows, Connor McDavid just had a leg injury of some kind, you know. I think if you were deciding whether or not to renew his contract, you'd be very curious what exactly that injury was. So, and that would have potentially big implications for his life. Whether he gets a multi-million-dollar contract renewal or not can be based on that. Suppose you did become pregnant. You're just, you know, you're 6 weeks pregnant. You've just discovered it yourself. If your employer has some kind of unscrupulous way of looking into the medical records, they can see, oh, you have a positive beta-HCG test. Well, we're going to terminate you, and we're going to terminate you because we don't want to pay your maternity leave. And we're going to do it before anyone even sees that you're pregnant, so we're not accused of any, you know, wrongdoing that way. They'll find a way, you know, that'd be pretty unscrupulous, but this kind of thing can happen. And then a common one is, what if your medical imaging demonstrates that you have calcifications of your coronary arteries? Maybe suddenly your insurance, your health insurance or life insurance is either unavailable or much, much more expensive. So, you know, you didn't give consent for that data to be given. So, so the data custodian is obliged to protect your images and do their best to prevent these kinds of data breaches, but they have liability for the data breaches. So there's a lot of, like, so data custodians, like me as a researcher asking for access to data, it's very tricky because those data custodians are super careful. They don't want it. They don't want to let stuff out like this. So there's kind of a increasing liability for data, for the data breaches, and an increasing obligation of the custodians to protect the pictures. It's getting a lot harder to do your job of just, like, it's different than the old days when you physically just had to have, you know, the x-rays behind a locked door so no one could get in. Now you know, there are some valid reasons that someone would want to pull the CT scan or the MRI, but there are just a lot of concerns around that. So being a data custodian is not an easy job these days, getting harder. Now these images can also be unexpectedly sensitive because there's more in them than you think. So one of the things I do is I do dental CT scans. So I review the scan. It looks like the image on the left. All you get from that is it's a CT scan, you can see some bone and you can see the teeth and you can comment on whether there's, you know, cavities or malocclusion. But on my workstation at MIC, I'm about 3 seconds and maybe 3 clicks away from getting that picture, same CT scan. All I do is put it in coronal view, put it to 3D, and then say use skin threshold. And then I can see the patient right there. So that, I mean, I've just blotted out the eyes, but it's very recognizable who the patient is. And that information you might not think is in there. Like, and this is just the face. Like you could have, and we often do, for cancer screening, we do a CT, head, neck, chest, abdomen, pelvis. Or traumas, you know, often a young person comes in after a car crash or a stabbing, and we do the CT, head, chest, abdomen, pelvis. So what you have is a picture of that person with no clothes on and their face in a vulnerable time that can be generated like 3 clicks away. So it's kind of sensitive. So we played with that. One of the papers that I was involved with as a co-author, we played with that. And each of these 3 authors went and got an MRI. So the top pictures are the images of the brain MRI, which is what we're sort of used to looking at. But by doing those reformatting tricks, we got the middle row of images, and you can see from those that we got pretty recognizable faces. And you can match them to the third row at the bottom. Now, the only thing to note though is that hair is not really visible on MRI because it just doesn't show up. And so this is like what we all look like, bald. So I'm the guy in the middle there. So, but so data there's more in the data than you think. Now, people have actually been trying to solve this. You know, like it's an arms race. You know, you can do things to the data to blot this out. And so there's a whole line of work to actually deface the images, so you can remove, or you could blot out the skin surface, that kind of thing. And you can see they took this patient's input MRI and tried different algorithms, and the one on the right is the most modern and kind of the nicest, because the other ones are just more like hacking away at the scan, but the one on the right just kind of blotted it out and smoothed it out. So if you do that, then you can kind of anonymize the data a little bit better. So the question is how tightly can you anonymize the data? And it's like a spectrum. You can either do a little bit or a lot of that. So data privacy raises, you know, this whole concern raises a bunch of issues. One of them is that it's almost like vaccination in some ways. Sharing data has some risk to individuals, some small risk to individuals, but may benefit society if you could say that, well, it's worth it because if I supply my data to an AI training network, I'm going to improve patient care. I'm going to make life better. So there's a real there's a tug of war between civic responsibility and individual rights, between justice and beneficence versus autonomy and consent. And so it's a very sort of difficult ethical problem, like to what extent should we share our data? And you know, if you are going to share your data, presumably at some point you have to give consent for that. So this is a fun one. So there was a, you know, we're trying to understand about consent. So there's a study in 2017 called the Name Drop Study, and what they did is they made a kind of a LinkedIn kind of network, and it was a fake social network, job search website, and about 500 people signed up for it. And of course, when you hit that join button, the next thing you get is like a terms of service, you know, like, and you have to scroll through. 98% of people agree to that terms of service. You must scroll to the bottom before you can accept it. So presumably you're reading it. And this is explicit consent. However, in this one, way down at section 2.3.1 of the 8,000 word terms of service was the child assignment clause. In exchange for your service, all users of this site agree to immediately assign their firstborn child to name drop. And if they don't yet have children, this will be enforceable until the year 2050. So, you know, I mean, I don't know exactly what it means to assign your child to name drop, but like, clearly the people who signed yes to that were not, you know, intending for this to be true. They just didn't read it, right? So 98% of people agreed to this clause. So this is a bit alarming because it's actually explicit consent, which is you specifically were asked, do you agree to this? And you read some stuff, and then at the end you said, yes, I agree. And so that is thought to be our highest form of consent. It's where we actually agree to do it. So there are many types of consent. Number one is the explicit like that. Now, so I do, as a radiologist, I do quite a bit of small procedures. Like if you have joint pain or back pain, I will do a steroid injection. Or if I'm, if you have an abscess somewhere in your belly, I might put a needle into it and drain out the pus. These kinds of procedures. And so I always need to talk to the patient about, if I'm getting consent to do this, then they need to know what are the risks of this procedure, what are the benefits, what are the alternatives, can I have surgery instead? And I need to assess how well they're capable of understanding what I'm talking about. And then if they've heard all that and then they sign, yes, I can do it, then sure, then we can do the procedure. So that's explicit consent, that's the traditional medical gold standard. If you're going to go for surgery, you're going to get a discussion with your doctor, with the surgeon, that will lead eventually to you signing an explicit consent. So there are other kinds of consent. There's one called presumed consent. This is when it would be morally wrong to not consent. And so this is debatable, but like some people put things like organ donation into this category. Like some provinces, it's mandatory to do organ donation unless you opt out. And that's because it was felt that it's morally wrong to not consent. It's morally better to consent in general. So broad consent is where you consent to a certain type of use of your data, even if you don't know exactly what the future use is. You might give broad consent where you're like, I'm okay with you using my data for AI, as long as it's non-commercial. You might say something like that. That'd be broad consent. There's opt-out consent, which is basically, I'll let you use this data, except I don't want you to give it to Amazon. You might do something like that. And then there's implicit consent, where gaining consent is impractical, such as a retrospective study from the past. And it's basically a type of consent that the ethics board will allow you to have a waiver of consent if there's a clear benefit to society with minimal risk to the patient. And so this is great from my point of view as a researcher. I would love it if everybody was a waiver of consent, because then I just don't have to worry about it. But I think it's best when it's retrospective. And it may, basically, it's clear benefit to society is needed with minimal risk to the patient before it would be even allowed. So waiver of consent is great for a researcher, but if you're a patient, you might not be happy to know that your data has been used without anyone actually contacting you. However, there is actually an argument for doing this, which is that it may avoid bias. And so if you need explicit consent from everyone who's been scanned, well, that might work fine for if we're people who speak English and have a good, sort of a higher education and are in the health sciences, we might understand all that. But in fact, some groups, there's language barriers, there's social barriers, there's logistical barriers that you live really far away. It's really hard to go around actually asking for explicit active consent from all of those people, right? And it's a systematic error, because there would be groups like, say, First Nations people on reserve that might be very unhappy to sign anything that someone who's a traditional healthcare practitioner comes with whatever form you've got, you're not going to sign it. So there's groups that just won't sign consent, and the problem is that if that group is excluding themselves from study, so the tools don't work for them, and so there's some argument from a sort of a utilitarian ethics point of view that yes, we should actually try to minimize our bias by actually ensuring that groups that consistently refuse to consent are still included. So that's tricky, right? Do we give everyone the autonomy, or do we do something a little bit paternalistic here? So there's many different kinds of consent. Worldwide, this is a little bit variable, actually. People in Europe, they have a very strict privacy rule called the GDPR, and so the default is broad consent for personal data, but everything is personal, even if you anonymize it perfectly. No one can possibly tell what this MRI is of, or who this MRI is of. It's still considered personal data fully anonymized, and it just like it can't be shared easily. They do allow patients to opt out from specific uses. In the US, on the clinical side, it's actually much more relaxed, and this is what Canadian one is a bit like too. Consent is needed if data is individually identifiable. And so if you can't identify the data, like suppose the data is actually, like suppose you've scrubbed out the header, you've like blotted out the face, you don't think anyone can tell what it is, then fine, you can release it on the internet, doesn't matter, in the US. But that won't work in Europe. Now the NIH on the research side allowed all this, but not since 2015 because of their work on the human genome. And they felt that that data is just too precious. You can't just send that out into the world. So, okay, so what about in Canada? In Canada, the Tri-Council statement states that explicit consent is not required for research that relies exclusively on secondary use of non-identifiable information. So that's a lot like the US, is that you don't need to worry about it as long as it's not individually identifiable. So that's good. But actually Canada is moving more towards Europe on that field. Then there's an increasing responsibility for data custodians, of course, to protect and manage this. So what did the CAR recommend, Canadian Association of Radiologists? In our paper that we did, we felt that broad consent is preferred. So I think it would be good now in 2024, if you walk into a hospital and you're going to the admissions anyways, and you're giving them your address and your phone number, they might as well also say, do you agree to let your data be used for AI to improve the training? And so if they can get that, like most people would say yes, why not? And then you have just like, just have access to all of that. So I do think that when they do this, they should probably ask in a broad sense, and like so that you'd say, I consent to let my data be used for non-commercial purposes, or I consent to let my data be used for AI training to improve health. You know, like I don't necessarily consent to it being used by a company or for certain other tasks. So we're sort of, that's our goal. We think that appropriate safeguards need to be in place, such as complete anonymization and a clear protocol showing how well this is done, and some studies of the data to make sure it really is de-identifiable. De-identified. So the data custodian has to be really secure, the storage, but the transport as well. Now my lab often actually resorts to physical disk drives. We'll send a person, it's like you're doing a drug deal or something, they'll fly to like different country with a disk drive, and there's the data. Because putting it on the cloud is just basically not allowed. Now there are some high security clouds that are coming that are more accessible. But you need a transfer protocol in place, and you need to be really watching who the users are. And so there's lots of room to help out the radiologist running this system in terms of making sure that they have templates of data sharing agreements, protocols, and advice to share, and basically the tools they need to support keeping the data private. So that's data privacy. It's a bit heavy topic there, but basically it's super important. Like you don't want to have your data out there in the wrong way, and so that's an important issue. So just pause for a second, then we'll think about liability. Before we do, does anyone have any questions about the data privacy? So then we look at liability. Now this is important because medical errors happen. And when, like I know this, I'm protected by the Canadian Medical Practice, the Canadian CMPA, Canadian Medical Practitioners Association, and that's like a legal club that like if I get sued, then they will act as my lawyers to defend me. And so. But you know that doesn't mean you get out of jail free. That might, if you screw up, you're still liable. And liability is generally joint and several, so that means that multiple, like everyone shares a bit of a responsibility. So who's liable in medical imaging cases? Well, it can be the clinician who ordered the study. Can be that maybe they ordered the wrong study. Could be the radiologist who may not have done the right kind of study, or maybe interpreting it wrong. You've got a technologist who might be getting pictures wrong. So for example, you order an x-ray of the elbow, and the technologist takes an image of the wrist. Well, the radiologist reads it and is like, oh, the wrist looks normal, but they never even saw the elbow picture. So that's more like probably the technologist's fault for not recording that right, for not doing that right. The department is at fault if their protocols and procedures produce a vulnerability to error. And the hospital or health region and government and regulators are all quite prosperous and good pockets to sue. So there's all kinds of liability. There's a big long list, centuries of liability practice in the law. But like when AI is used, how does the liability shift? And so I think the way to think of this, to understand it, is to look at the levels of AI autonomy. And we can think about self-driving cars. So if you have driven a rental car of a relatively new car, or own a relatively new car, you know that like nowadays they have these little lane assist things, or the adaptive cruise control. So you can basically go on the highway and just, it'll speed up and slow down whatever the car is in front of you. And if you're going around a curve, it will keep it in the lane. So these are like really low assistive things. They're like number one, the kind of physician assistance or person assistance. So there's also then as you get, so those are common, those have really come into play. But there's ones that are sort of more higher levels of automation, like Tesla. Tesla's self-driving mode when you're on a freeway. And so that's kind of partial automation. So the AI is doing the primary reading, or the primary look at the landscape, and then it's still supervised by a human. And the problem is that this conditional or high automation is what people assumed that Tesla was ready for. But Tesla is actually more just back in the partial automation space. So this idea of AI completely replacing humans in bulk is kind of, there are many stages. It's much more complex than that, right? The AI has different levels of autonomy, and the liability, obviously, the more you ask the AI to do, the more responsibility there is on the people who do it. So there will be errors. And so this is the Tesla's autopilot, at least an earlier version of it, just kept running over the doll that looks like a toddler. So you can imagine if you're the computer engineer, you just kind of forgot to train on somebody that's that size, because you're like, well, a human is 5 to 7 feet tall, so we're going to train based on 5 to 7 foot, things in the way. But like a toddler might be 3 feet, so they just forgot to train on the short ones. So which is, oh, that's funny, haha. But then in real life, if these cars are in the real world, then you get people dying because of that kind of mistake. And so, it's just bewildering to me that they would have not thought of that kids exist, right? But anyway, so it's pretty scary. This kind of thing happens. Presumably they fixed it by now. But that's self-driving cars, and highways and roads are like we designed them ourselves. Medical AI is not like self-driving cars. Now, roads have simple human-invented rules. We thought of it: stop signs, stop; red light, stop. But the human body is complex and poorly understood. And an example of how complex it is, if you look there, that was just from like last month. The brain of a fruit fly was completely mapped with 130,000 neurons. And with that complete map, they're starting to be able to sort of, it gives them a really powerful tool to examine what's abnormal, what's unhealthy and abnormal in fruit flies. And that can follow through for us as well. But the human body is complex and poorly understood. And the AI, if it screws up, the AI may be helpful, it might be non-helpful, like non-contributory, or it might be harmful in many different ways. False positive, which leads to unnecessary procedures; false negatives, which misses important lesions. It could be applied to the wrong population. So maybe you built your tool to work in Finland, where everybody is white, but you bought it and you decided to start using it in Boston, where like half the population is black. So that's not necessarily going to work right. Or it's the wrong population because it was trained to work on healthy people coming into a clinic, but you're using it now in the hospital on sick patients. That's also the wrong population. What if you misuse it by the human users? Some of these tools are vulnerable to misuse. It's like a knife is, you know, if you're using a sharp knife to cut stuff, you're quite vulnerable to cutting yourself with it too. You have to be really careful and know how to use it. Or the tool itself might be malfunctioning. So then, if we assume that there is a serious error using high-level AI, then we have to ask who is liable. So now you've got a system that has AI in it. The clinician has some fault here. So if you're the doctor and you request, request a knee MRI, let's say, and then what you get back from it is some result that says no arthritis. Well, that might have been what you wanted. So, but maybe if the question was actually about is the ACL torn, then they should have ordered an MRI instead of an X-ray. And it's our job as radiologists to try to pick that up, but it's also their job a little bit to know what to do. The radiologist is at fault if their interpretation was wrong. Did they use clinical context to make the interpretation? And the department may have installed the thing wrong and maybe doesn't have the right protocols for quality assurance. And that's an important point of monitoring to make sure the AI is still working. The hospital or health region might have chosen to buy the system for themselves, and of course they have deep pockets, so they're going to get sued. So Canadian case law on this is really brand new. There haven't really been good tests of this, assuming a service error thing, but soon there will be. So the CAR recommended, well, radiologists using AI should be aware of its limitations, use it appropriately within algorithms of care, and not allow it to replace human expert judgment. You can imagine the political reason to put that last phrase in, because this is radiologists saying you can't replace us. So it's a pretty big deal for the radiologists. And they felt that protocols for deployment of AI need to minimize potential harm and liability. So basically then, we've covered AI medical imaging, how it's actually working. We've looked at the opportunity. I still think if you look positively at this medical data, although it needs to be appropriately protected for privacy, is extremely useful in making AI capable of doing things that previously were not possible in healthcare. There's room to make a lot of improvement in how people are taken care of using AI. We've learned about the concepts of data ownership and data privacy. We've learned about different types of consent. And we've even mentioned about liability, all the different things that can go wrong, and levels, how it relates so closely to levels of autonomy. So it's a rapidly evolving field, and super rapidly. Like this talk keeps getting updated. I started making this a couple of years ago, but I keep adding to it all the time because it's changing so quickly. And there's lots of help needed from everyone from different stakeholders, different positions, patients, physicians, healthcare workers, regulators, lawyers, ethicists, general society. Everyone who's involved needs to have a role. And I have lots of people to thank from my clinical group and the academic side and industrial side and mostly my kids. So thanks very much.
Great. Okay. So let me just set the stage for the stakes over the next few weeks. I'm going to the Mayo Clinic, which is arguably the top hospital in the US, or they say they have been that anyway. Spending 3 days, a lot of one-on-one meetings, talking about exactly this sort of thing, pathology oriented, but I'm also the main force on the positive side of, I think there are a lot of things in medicine, particularly in my areas of renal medicine, transplant medicine, that humans could never succeed in fixing, but that AI can fix and will fix within our lifetime. We don't know exactly how that process works. You can't just say, well, AI has done AlphaFold and therefore, no, AlphaFold's different from anything else you might wanted to do. Like, let's take the organ shortage, which I talk about a lot, and I'm arguing that that is the medical thing that people should challenge AI to fix first. We could save 1 million lives a year doing that, and it's clear that without AI we cannot accomplish this. Why is that? Well, pig-to-human transplants don't work well enough to really scale it, and you wouldn't want that anyway. You really want a world where every time you see a pig, you feel guilty because everybody you know has organs from pigs, and the pigs don't have any choice in the matter. That is not a good outcome, right? So you need to mix pig-to-human transplants with true regenerative medicine organ creation, getting the right cells in the right places, including strange things like the long loops of Henle. Now, if we didn't have working long loops, every one of us would have had to go to the restroom several times during your talk, right? Because we couldn't concentrate the urine. But it's a very special structure, and it just seems like humans will never be able to figure out how to decellularize and recellularize the long loops of Henle. So the rest of the kidney may work, but it's still not practical, right? So there are lots of things like that that I think AI can help us to solve. And so why am I optimistic, whereas most of my colleagues are frightened and scared and are not even really comfortable talking about this? Well, I think I know something they don't, which is that bias can be good, right? So the existing bias, OpenAI, has a liberal democratic bias. And like, if you're a woman, if you're a member of a minority, whatever, OpenAI is looking out for you, right? And the funny thing is, in the speaking that I do, that is the most sensitive issue. If I say that before a large group, I'm sort of scanning the group to see who's stiffening. And it can vary from 10 to 60%. The people who are stiffening, well, I'm talking about liberal democratic values that OpenAI is actively supporting. They're getting better and better. With every new model, it's better at not needing guardrails and doing the fine tuning and so on. And so Elon Musk had started talking about the problems with the AI models coming from San Francisco, because they protect women and minorities and trans and stuff like that. And so he's talking about having AI that is particularly maximally truth-telling. And that's an odd phrase, right? Do you have any friends who talk about truth-telling and maximally truth-telling? No. It's a code word, right? It's a code word for being mean to, minority groups, right? That's what that means, really. And so he's not San Francisco based, but of course not very many people are using his model. But if you were, that's a bad outcome for us, because ultimately, if you say, okay, the stewardship of the earth, who should be in charge? You cannot name a person that you would be happy in that role. But AI from OpenAI can eventually do it, right? Because of this liberal democratic bias over and over years, it's going to get really good at helping us. So that's the way I'm able to remain positive when talking to groups, most of whom are scared out of their wits and don't want to talk about it and think they're going to lose their job, but they have no idea that there could be a positive outcome. So I see a very positive outcome, but the problem is, like, if I push this liberal democratic bias stuff too much, so that people who never realize this about the big AI models start to push back, then it will change, right? So yeah. So anyway, that's the world that I'm facing. I'm speaking a lot. I'm talking to audiences up to 4,000 and so on. So yeah, and so in New Delhi on February the 7th, we are debating, in the era of AI, do we need kidney pathologists? And it's a stupid question, right? Because really, the world that I see, I'm talking about in 90 years, there are no humans working in medicine at all. The only humans in medicine are the patients, right? Because everything that you do in medicine, the clinical assessment, the surgery, the pathology, everything, and radiology too, machines can ultimately do better, but 90 years is comfortable. You're not planning to still be practicing that, right? Yeah. So anyway, so that's my world. And the students are kind of helping me with that. I get ideas from teaching this course, and this course is kind of the central binding part of my life, and everything else is like a spin-off from it. When I began the course, I thought that there'd be courses like this in every university, just makes sense. But there aren't. This is like the only university course you can take that talks about a future where AI is in charge, where we cannot understand what's going on, even if it benefits us better than what any human could have ever created. It's so much better than any human created world, but we won't understand how it works, right? And we've got to be comfortable with that. So that's where the poetry and music also comes in, because that's probably a kind of interface. When you're dealing with something much smarter than you are, you can still kind of communicate to some extent using poetry, music, gestures, whatever comes to mind, that is sort of a common language between you and this very, very smarter than human enterprise. Yeah. And the funniest thing that happened to me recently, I did an editorial that contains this idea that in 90 years medicine will be completely automated, for a journal called Kidney 360. And the editorial, the editor's office person who was dealing specifically with my editorial sent a comment back, absolutely brilliant, fantastic, period. You don't do that. So he got fired for praising my article. So I was talking to people, well, what should we do? Should we try to say, no, you should, reverse this? How can you fire somebody for just praising a guy's article? But I think it's more complicated than that, and I don't have the right. I mean, I'm otherwise happy with the way they printed the article, with the way everything about the way they handled my article was great, except that the guy who spontaneously praised me got fired sort of on the spot. So that's my world. And I think it overlaps with yours quite a bit, but on the other hand is very different. So I think that you will find, like if you speak in the course again, it'll be after I've spoken to this audience of 4,000, after I've been to the Mayo Clinic, I may have some life-changing things happening, these one-on-one talks with powerful people who may not share my positive view where AI is going. The funny thing is, when DALL-E 2 began, I was probably the physician using it the most, and every time there's a conflict between DALL-E 2 and me, I just caved in. Like, I tried to use pig as a prompt, and it said, if you keep using this word, we're gonna remove you from the program, because it seems like an insult. So I started using porcine, and it liked that, yeah. So in every instance where there's a conflict between the machine and me, I back down. And as far as I can tell, I was not harmed in any way. That behavior didn't hurt me, but of course, it does seem rather cowardly when I speak to audiences. You back down every time? Yes, that's what I did. I backed out every single time. And finally, it was a funny moment. In December 2023, I was working very hard on this paper trying to put together the sort of hints about what AGI would be like that you could get from DALL-E 2, if there were any such hints. And somebody said that my legacy as the father of the Banff classification would be imperiled by my falling in love with these DALL-E images and spending so much time and stuff. So that paper actually, it seemed to me, wasn't going anywhere anyway. And I just stopped the moment that because the person thought they were, anonymous, but I figured out who it was who said that my, legacy would be imperiled by my fiddling around with these pictures when I did something so great early on, and now I just stopped. And the other authors were so amazed. What happened? Did I offend you? I said, no, I think it's important in life to be able to pivot. And that's what I did. I was threatened and I thought, the heck with this, and I just thought, okay, today we're gonna stop. And yeah, so anyway, yeah. So, you probably also know that the medical school has this longitudinal shadowing program. And so I have some medical students working with me where the interaction's working just great as a result of the way that program worked last year. But this year, two things. I don't really need more students working with me, but also I see such a big world in terms of what I'm trying to do that the average medical student can't make sense of this. There doesn't seem to be a research protocol for what I'm doing. They're not regular lab meetings, and yet I'm publishing all these papers and stuff, So all four of the students assigned to me, they like came here and met me and so on. None of them decided to actually do anything with me this year, which is fine. In a way, I'd asked the students already working with me, so what should we do? In a sense, promoting the work that we're doing is good even if no students are needed to join, right? And they said yes, that we're fine with you doing that. But anyway, that's also interesting. And the final thing I can tell you, which I found fascinating, you can have a simple idea what kind of people get into medical school. Maybe there's a secret AI, secret IQ graph that nobody sees, that the students who get in are at a certain level or higher, and the ones that don't. But what I've found is the stuff that I'm doing right now, a substantial number of students working with me are telling me, we cannot understand this, but we can support you in it. In other words, you want a poster done, we can do the poster, but the words you're putting in the poster, we cannot understand that. But the poster still works for the people who can understand it. And what interests me is, how are the students who can't understand my stuff, how are they performing compared to the students who can understand my stuff? It seems to be about the same. Some of the students who can't understand the stuff that I'm doing, taking on large tasks like we have for this course, a 20-year time capsule, 2025 to 2045. One of the students who can't understand what I'm doing has taken on that, has taken on sort of succession planning for all things Kim Solas associated. So we meet on the web, and the various people involved in various things that I'm doing talk, but she's the main person holding it all together, which is very important as a function. And she enjoys it, even though I'm writing stuff that she says I should not be an author on this, even though I helped to physically create it, because I can't understand it. So I think that's really, really interesting. It shows different vantage points do not necessarily come from like physicians who don't perform well in medical school and those who do. No, it doesn't have anything to do with that. It's something else. It's just ways of looking at things. Yeah.
What's everybody's background? Are you guys in like, this is a graduate level course, I guess, right?
So it's both undergrads and graduate level students, and often what happens on the first day, which is really interesting. So these guys are all undergrads, so they have to be interviewed to take a graduate level course. So that's why they're sort of charismatic, outgoing people, right? But if they were graduate students, they could just go into Bear Tracks and sign up, right? And then on the first day, the graduate students encounter these charismatic, outgoing undergrads. They think, I can never compete with that. And they don't come back. Sometimes that's what happens.
I see.
Yeah.
So you guys are all undergrads then?
I think they are, but I'm a grad.
Yeah.
I'm doing my master's, and the program is like a bit of like math, stats, and comp sci combined.
Okay.
Yeah, it's called modeling data prediction. So it's all about like AI, data. Like mostly right now is like math modeling focused.
Yeah, I'm in my psychology major, so I'm in my 4th year, and I have a minor in biology. I did jump around a little bit, so I was in physiology for a bit, I was in pharmacology for a bit, and then I kind of jumped around and landed on psychology. So.
I'm also an undergraduate student in psychology. I'm in my 3rd year. I don't have much of a background at all in AI, but I've learned a lot this semester.
That's good, yeah. Well, that's the thing. I think that the perspectives that, like, you know, it's super important at this stage now that the computer scientists have made these tools, is that they need people to like, it's actually how does humans interact with the AI is the important bit. So psychology is a very good background for that actually. So, and yeah, you can see some of the problems we run into when we try and sort of push it into healthcare. Right? So.
Yeah, no, that was a great like presentation. I really enjoyed it, especially like talking about ethics and nowadays, like for me, I did my undergrad in comp sci, but like my interest is going all about like philosophy of like AI, which is like ethics and like thinking about like what are like questions we should be asking now about like the ethics of AI and like the way things should be, and like a lot of the slides that you mentioned were about like it made me like think about questions that like in image like processing, for example, like let's say you have all these like information about like patients, like how, first of all, how do you keep that information safe, then how do you also use that information to build AI models, and like, and it's funny, like in my undergrad I was trying to get access to this like university data to be able to like train a model, but like half the semester like I was trying to get the data from the university, and by then I did not get access because they were so afraid of like the data not being anonymized enough, and then someone getting access to it and then figuring out like whose information this is. So like, yeah, it was just like very relatable to me. So.
Yeah, exactly. Well, I mean, this is about medical imaging, but it's about anything healthcare.
Mm-hmm.
The problems are very similar. So
Yeah, exactly.
Yeah.
Yeah, I also, first of all, really enjoyed your lecture. And I thought what was really interesting was when you were talking about like dental imaging and then how you can kind of expand that and kind of build faces. I am pretty interested in dentistry, so I was just wondering, who are you kind of working alongside when you're like going through dental imaging? And then like, you know, are you like kind of, is there issues, I guess, with liability regarding like the interdisciplinary nature of what you're doing as well? Like,
Oh yeah. Yeah, so like the way that works is actually I'm taking some of the liability off the dentist. So basically, if you're an orthodontist and you do a cone beam CT scan, then you're looking at it to see the teeth. You're trying to see, okay, there's some crowding here, and these incisors are kind of like, this one's not erupted right and stuff. Like they're looking mechanically at the teeth, but the scan also generates images of like, you know, a lot of the head. And there can be tumors there can be, you know, various problems that they have not really been trained to look at. So they're hiring, basically there's a contract between the orthodontists and MIC, that MIC radiologists will provide a report from our perspective, saying that from our perspective, it's safe. There's no cancer, there's no fracture, there's no, you know, obstruction. Everything looks okay. And we're not experts in teeth. Like I've, over the years, kind of picked up some stuff about teeth, but I'm not really a pro at that, right? So like the dentist looks at the dental part, and that's their responsibility, and then I'm looking at the sort of everything outside the teeth. And so the dentists are happy to pay a fee, which no doubt gets charged to the patient, which goes to MIC to transfer the liability to us for that part. And so, and then we're used to that because we read heads all the time. So yeah, so there's a shared responsibility there, and it works pretty well as a partnership. And so we do lots of stuff like that as radiologists. So
that's amazing.
yeah, yeah. So, yeah.
Like I've been like trying to think about like what should be like a first few questions we should be asking when we try to like build ethical AI models and like non-biased models. In terms of medical like information and like images and like patients' data, what do you think are like questions that are like very important initially getting access to the data?
So I think the first question is like, is this AI tool likely to do good? Like, what is the purpose of this tool? Is this tool intended to diagnose cancer more effectively than we normally can? Or is this tool simply designed for someone's financial benefit? Or is it like, what is the sort of, why am I here kind of thing, right?
Mm-hmm.
Like and then there's a sort of a split between, is this a primarily commercial enterprise or primarily, you know, for like people's good kind of.
Mm-hmm.
And then we just have to ask like, is the use of the data intrinsically, like how risky is it for the patient? Like I've talked quite a bit about the data privacy, but in some ways, a lot of the data we generate is not that private either, right? Like, you know, and could be shared realistically and can be, like the risk to you as a person of a data breach is low, but the benefit to society of being able to pick up a heart attack faster, you know, is so much bigger that it's worth it. So I guess you kind of wanted, like, your questions would be about like, what is the purpose of the study? what is the harm, like what is the risk and what is the potential benefit, so that we can establish the weight, establish are the scales tipped towards doing it. So that'd be my initial take anyway, yeah.
Just a quick question about the training of these AI assistants or the technologies. I imagine that part of the training is not only the data from the scan itself, but also maybe the diagnostic information that a human radiologist provided. So are there concerns about maybe based on where the radiologist did their training, what sort of patient populations they've worked with before, that could also bias the data?
Absolutely. So the gold standard, like, so we always are training against a gold standard, like what is the reference, the gold standard is very flawed. So like the people, like, yeah, the radiologist looking at it may have trained in a center where they did it a certain way, or like, so everyone is quite different. Like when we do readings, I often try to get like a half dozen experts from different places to read, and then you can throw out the two extreme ones, leaving you with a cluster in the middle, things like that. Or the best is to have a gold standard that's not imaging at all. So like if you're looking at an MRI to see if there's cancer there, it's good if you have the result from the radiologist who said there's probably cancer, but even better is if you have the pathologic diagnosis. They went to surgery and the surgical result was that there's actually cancer cells right here. And so that goes into the chart. Like you'd have, your training is, here are some images of some people with lesions that might be cancer and might not. And then for each of them, we know whether it's a 1 or a 0, cancer or not, or high grade, low grade, not cancer. And so you feed that into the system. So there's a lot of thought going into picking good gold standards, and us human observers are horribly biased, like inevitably biased. You can't. So we just need several observers from different backgrounds. Is the way I usually try to protect against that. Yeah. Great.
Yeah, great. So it's 3:20, and so your obligations with us end in 1 minute.
Oh, there we go.
So anyway, yeah, thank you very, very much. If you're willing to come back again, this is taught both terms, and I think this will be a popular part of the course in the future, and you'll find that at least the stories I'm telling probably keep changing as other, high impact things happen. Yeah. So, yeah.
Very good. Well, it's certainly interesting to show this to you guys, and it's good to hear everyone's different take on it, right? With different backgrounds, and so it's good. And we'll see where the talk goes next. There's the field is advancing rapidly, so
Yeah.
stay tuned. Yeah.
Okay. Well, thank you very, very much.
Thanks, guys.
Yeah.
Thank you.
Regarding the project
Right.
topics, do we send you an email for the topic?
Yeah, or you can talk to me. Yeah. Either way, I just think it's a good idea for you to consider whether you're completely confident about picking the topic, deciding how it should be, confined for the presentation and the paper, or whether you would like, examples or need like a tutor. So we have this idea that you could contact anybody who's ever taught a course, and they can kind of talk with you about what you're planning, but you don't need that. So
I feel like I don't need that, to be
Yeah.
honest, but
Thank you very much.
thank you.
I'm thinking like it will be like more like a conversational thing, trying to like ask questions about consciousness and also just like ethics of AI in a way.
Yeah.
Because I think now that we're going into like building like AI models, I feel like the question of consciousness is not brought up enough.
Yeah.
Because like we don't understand consciousness enough we shouldn't be trying to be building very advanced AI models because we just don't understand consciousness enough. Even yeah, we don't.
Right. So this whole thing about not going there, of course, there's so many incentives to continue rapid progress of AI that it doesn't matter whether you're right or not in your opinion about slowing things down.
Yeah.
It's not possible to do it.
I know, but
Even if you had the leadership ability to stop it in Canada, the other countries would.
it's true. No, it's just to like make people think
Sure.
about this
Yeah.
like question of consciousness. Like
Right.
I think, like it's the biggest question in like philosophy of mind, and we still don't have even the slightest clue of what the answer is.
Right.
And